Hi, I'm Josh and I work at Roseman Labs, and today I'm excited to show you some new functionality that's part of crandas 1.14, the random forest classifier. We're going to use this to make predictions on a famous machine learning dataset, the Titanic dataset. This dataset contains a list of the passengers that were actually on the Titanic on whether or not they survived. It can be found on Kaggle, for example, should you wish to try this yourself. And let's use this dataset to try and predict the ending of the James Cameron movie, the Titanic. So let's start by actually importing all the necessary modules and connecting to the environment. We'll just use a design environment for this because it will just be easier to show you. So now that's successfully done, let's upload our dataset to the engine. You can see that's all gone fine. We've got the handle. So let's get started by preparing the data. Let's just have a quick look at a sample of 5 of the rows, just to see what we're dealing with. So it's interesting, we've got a few columns here. We probably don't need the passenger ID. Survived we're obviously going to keep because that's what we're trying to predict. We've got P class, which is the class in which the passenger actually travelled. We've got the name, probably also going to remove that because it doesn't help at all. Sex we'll keep, but this is in text, so we need to remember to convert that into numbers. Age we'll also keep. We've got SIBSPA, which is number of siblings and spouses. We've got parched, which is the number of parents and children. Ticket number, we obviously don't need that either. Fare we will keep. Cabin also, we don't need the number. And where they embarked from, for the city, we also probably don't need that. So what we're going to do is we'll create a subset of the ones that we're actually going to use, which is survived, the class in which they travelled, sex, age, SIB, SPUR, parch, and fare. So let's actually create this. So now we're working with a kind of more limited data set, which is easier. I see that age is actually a nullable column denoted by this question mark. So just to make it easy and avoid problems, let's just drop all of the missing values. It's not essential for random forest like it is for logistic regression. But yeah, I think it's an easy way to do that and make sure we don't have any problems later on. As I also said, the sex is currently in text. So what we're going to do is if it's male, we're going to make it a Boolean, i.e. this is a number and equal to 1 if they're male. Now that we've got our data prepared, we're going to train the model. So we can divide our table into 2 tables. We've got features, which is what we use to make the prediction, and the labels, which in this case is survived. And we're going to make sure it's a number. So 1 if they survived, 0 if they do not. So let's do this. Okay, that all looks fine. So now we're going to move on to fitting and predicting with obviously the random forest itself. So the model will be the random forest classifier. We're going to get 10 decision trees because obviously random forest is just a lot of decision trees, and we're going to take kind of a majority vote across those decision trees. So it's more robust and less prone to overfitting, which is why you're going to use this. We're going to fit it with the features and labels that we defined just above. And we're going to actually determine the classification accuracy to see how well our model has performed. So actually now it's completely done, 40 seconds roughly. We get pretty good model accuracy, which is very similar to what you would get if you perform the data analysis in the clear. Just check that everything's worked. I've pulled out, we're going to pull out a couple of the decision trees actually. So I've picked 1, 3, and 5 because there's 10. So let's just show a couple of these to show that it's all kind of worked. Perfect. So you can see there's now a number of decision trees that have come out of this. There's actually 10, but I've only chosen to show these 3. So it all seems to have worked nicely. One thing to also note is that crandas does offer the train test split as well, so you can divide your data set into training and testing such that you can actually measure the performance on the test data set should you wish. And now let's get on to the interesting stuff. We're going to see whether or not Jack survives the Titanic. So we're going to create a data frame, Jack only, with the same features that we had here. Notice there's no survived because that's what we're about to find out. And we're going to use the model that we just built, our random forest, to predict whether or not Jack will survive. Unfortunately, no happy ending for Jack. 0 indicates that Jack dies. So hopefully this hasn't spoiled the movie for you. Hopefully you enjoyed seeing the random forest in action. Like, comment, and subscribe for more videos like this. Thanks, and we'll see you soon.